Hello, I welcome you all to this another interesting screencast. This problem is coming from the Engineering Mechanics Dynamics 14th edition by RC Benam. So we have a particle here, and its mass is 0.5 kg, and it is confined to move along the smooth vertical slot due to the rotation of the arm or air. So we are dealing with a problem in the vertical plane. Therefore, it means we are going to the weight will be pointed down. We have been asked to determine the force of the rod on the particle and the normal force of the slot on the particle when theta is equal to 30 degrees. The rod is rotating with a constant angular velocity, and we've been given the value. Assume the particle contacts only one side of the slot at any instant. Alright, let's draw the free body diagram. So we have the weight. Okay. So let me first draw the coordinates. So we are using the polar coordinates. So we have the radial coordinate in this direction, or R coordinate, and then perpendicular to that we'll have the theta coordinate. Okay, something like so. So this is theta and this is R. Right. Then we do have the weight. We have the weight. There we go. The weight. And then we have the force on the particle from the arm. It's perpendicular to the arm at that point. Right. And then we do have the normal force. So we have a force like so. Let's say the normal force, we assume this direction. Again, you don't have to worry which direction you assume. If you made a mistake, then the calculation corrects itself. So let's say we have the normal force in that direction like so. So this is the normal force. This is the force from the arm, and this is W. So we are going to resolve all these three forces into the coordinates that we are using. But before we do so, let's establish the angles or the directions. So this angle here is theta, you agree? So if this is theta, this becomes 90 minus theta, and this is theta, right? Great. So if we've established that, then we can say this is also theta. Alright. Then if that is the case, if this is theta, then we know to say this also is 90 minus theta, and therefore this is theta also, right? Alright, so this is also theta. Great. So with this information, we can quickly write down these particular forces, resolve them into components. So we'll have one component for n in that direction, and another one in that direction like so. Alright, let me use blue. Again, no big deal about the preference, I mean the colors. I just want them to not to mix up too much. So these are the components of n, right? And then we'll have components of f. We'll have one in this direction, sorry, not in that direction. We are trying to, so this one is already in this direction, so f will not have any component, sorry. W will have components, one in this direction, this is W, and another one in this direction. Okay, Is that so? Great. Let's label them. So this is W sine theta. This is W cos theta. And then this one here, it is N sine theta. Then this one is N cos theta. Okay. So let's write down these things. So there we go. This is our arrow. All right. So let's work out what is our arrow. Our arrow here is arrow. We know arrow. Can use trig to say cos theta is just equal to adjacent, which is 0.5 divided by arrow, which is the hypotenuse. Therefore, arrow is just equal to 0.5 divided by cos theta. Right. Then our arrow dot, which is the derivative of arrow with respect to time, just becomes, we're using quotient rule, so we can factor out this, and then we'll have a 0 by cos theta. Remember quotient rule, minus theta dot sine theta. Remember this? I know you remember, divided by cos theta. So therefore our arrow dot is just equal to 0.5 minus in fact this sorry, it will be negative. I forgot a negative. We'll have a negative there, okay, because when we work out the derivative of cos, we have a negative sine theta, like so, right? Remember that? I'd forgotten a negative, sorry, like this. Therefore, this just becomes 0.5 theta dot sine theta divided by cos squared theta. Okay. Then add a double dot. So here we use the product rule. We have three functions, theta dot, sine theta, and cos theta squared, right? So we are going to be working out the derivative of one, then we hold the other ones constant. Remember? Yes, I know you remember. Right, I know I can hear you saying yes. So we have theta double dot, like so. Then we leave the rest constant, right? Like so. Then we say plus. This is just one of the ways of working it out. Then this becomes constant. And then we work out this. We'll have theta constant, like so. Cos theta. Then of course this also we leave it constant. Then we have plus. So we'll have plus. Then we have this constant and this constant. Then we factor out. We want to work out this. Now we're using the quotient rule. Remember, we're using the quotient rule, okay, for this. So we'll have a 0 cos squared theta, and minus this just becomes a 2, then theta dot, not 2, sorry, 2 cos theta, okay, then theta dot minus sine theta. Okay, then everything we are dividing by cos to the power 4, right? Then we close this. Then therefore our other double dot, writing this, then we can write it from here just for sake of space. This just becomes 0.5. We have theta double dot, and then tan theta divided by just cos theta, and plus theta dot squared, theta dot squared, and divided by just cos theta. And we do have, and multiply this, we'll have a plus, we have a plus 2 theta dot squared, this and this, and then later on we'll have tan squared theta. So 1 cos and cos cancels, then divided by just cos theta, right? Yes, so 1 cos and cos cancels, so we'll have there like so, just remain with 3. Then sine squared, and cos squared, tan, then we'll remain with 1 there. And this minus and minus, this part and this part goes. Great. So our double dot, we can write this again as 0.5 divided by cos theta, and then we just have theta double dot tan theta plus theta dot squared plus 2 theta dot squared tan squared theta. Okay. Alright, so with this information, let's now work out the values. We do have theta itself equal to 30 degrees. We have theta dot, which is equal to 2, and it is constant, right? And if it is constant, we know that our theta double dot will just be equal to 0. So if that is the case, then this part goes to 0. Great. This part goes to 0. Great. So let's work out these values. So let's find out what R is at theta equal to 30 degrees. We do have these functions here. Our R, so is 0.5 divided by cos 30. This just gives us a 0.5774. Okay, then we have theta dot at theta equal to 30 degrees. Okay, where is it? Theta dot, there it is. Let's work it out. So it's 0.5 by theta dot is 2. So this, let's simplify this further. So this just becomes 0.5 theta dot tan theta divided by cos theta, like so, right? So 0.5 by 2 tan 30, okay, divided by cos 30. So this just gives us a 0.6667. Okay, 6667. Then we do have R double dot, okay, at theta equal to 30 degrees, and this is just equal to let's work it out. So we have 2 by 2 squared, tan 30 squared. Okay, so 2 by 2 squared, tan 30 squared, okay, plus 2 squared, okay, then times 0.5 divided by cos 30. So this gives us a 3.8490. I repeat this, 2 by 2 squared by tan 30, okay, plus 2 squared by 0.5 divided by cos 30, 3.8490. Alright, I think we found everything. Let's now write down the equations for the acceleration along the theta direction. Right, so what do we have? You know that our AR is just equal to R double dot minus R theta dot. Okay, this is just equal to 3.8490 minus R, and our R is just 0.5774 by theta dot squared. Therefore, our AR will just be equal to 3.8490 minus R, and our R is just 0.774 times 2 to the power 4, to the power 2. So this is 1.5394. Then we have A theta, which is R theta double dot plus 2R dot theta dot. This is equal to our R is just 0.5774. Our theta dot is 0 plus 2 R dot is 0.6667 by theta dot is just a 2. Therefore, our A theta is just going to be equal to 2 by 0.6667 by 2. So this gives us a 2.6668. Alright, then let's sum up the forces. So we do have our acceleration kinetic diagrams in this direction like so, and in that direction like so. So this is our AR, this is our A theta. So what do we have in these directions? So say summation of forces in the R equal to MAR, going that direction being our reference. So we do have, this is our reference, we do have N cos theta minus W sine theta equal to MAR. Okay, N cos theta, and our theta is 30 degrees minus 0.5 by 9.81 sine 30 equal to 0.5 by AR, which is just 1.5394. Therefore, N will just be equal to 0.5 by 1.5394 plus 0.5 times 9.81 times 0.5 divided by cos 30. This gives us a 3.72 newtons. 2.5153 that's 994. Okay, plus 0.5 by 9.81, 9.5 divided by cos 30, 3.72. Great. Then we do have, and this is in this direction, then we do have summation of forces in the theta direction equal to ma theta, going in this direction being our reference. We do have f, minus n sine theta minus w cos theta equal to ma theta. So our f minus n, which is just a 3.72, 3.72, I'll put 3 4 decimal places, 3.7207, that is, I still have it on my calc here, 7207, sine 30, w is just 0.5 by 9.81, cos 30, and this is equal to 0.5 and then 2.6668, and therefore our f will be equal to 0.5 by 2.6668, okay, plus 0.5 by 9.81 cos 30 plus 3.7207 sine 30. Alright, so our f is just 7.44 newtons, and it is in that direction like so. Alright, I guess this is about it. We have found the normal force, as well as the force that is exerted on the cylinder. Okay, that's a cylinder, right? Or on the particle. Alright, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in the next screencast.